Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to look at algebraic proof, and we're going to look at all the key facts you need to know to be able to prove something algebraically. Now, when you're proving algebraically, it will say in the question, make sure you use an algebraic proof or use algebra to prove your answer. So they do give you the key words in the question, algebraic and the word proof. So you know that you have got to use algebra, which is either in terms of n or in terms of x, to be able to answer the question. Now, the first key fact you need to be able to answer any algebraic proof question is that you need to know what an even number is. Now, if you take any integer n, okay, so any number n, and then you double that number, it will automatically become an even number. So our first fact that you need to write down is that an even number is equal to 2n. So write it down, put a bubble around it, make sure it stands out that you know that an even number is 2 times n, because any number multiplied by n or any number doubled will always be an even number. Now, if I know an even number is 2n, to calculate an odd number, all I need to do is take my even number and add 1 to it. Will make it an odd number. Or I could subtract 1 from it to make it an odd number. So if I start with 2n and I add 1 to that even number, it will make it odd. Or if I subtracted 1, it will also make it odd. The next key fact is to do with the word consecutive. And you need to know what the word consecutive means. And consecutive numbers are numbers that are next to each other. So your most basic consecutive numbers that you will come across will be the number n. Then the next number will be n plus 1, so adding 1 to that number. Then add another 1 to it gives you n plus 2. These are consecutive numbers. I now need to look at consecutive even numbers. So when I'm looking at consecutive even numbers, I'm going to start with my first even number, which is 2n. Now, if I add 1 to 2n, that will take me to an odd number. So I want the next even number. So I can't add 1 to it. I've got to add 2 to it to make it the next even number. Then, consequently, once I've got 2n plus 2, I then need to add another 2 to it to make it the next even number, because otherwise, if you only added 1 more on, it would make it an odd number. So these are my consecutive even numbers. Consecutive odd numbers, we can start with our odd number, which is 2n plus 1. Now, here, 2n plus 1 I've written in the middle. Now, earlier when I explained about an odd number, I said we start with an even number and you can add 1 to that number or you can subtract 1 to that number and it will be odd. So here, if I've subtracted 1 from 2n, 2n minus 1 is an odd number. 2n plus 1 is an odd number. And I add another 2 onto this, so 1 plus 2 gives me 3. So 2n plus 3 is also an odd number. These are 3 consecutive odd numbers. You could have started with 2n plus 1, 2n plus 3, and then 2n plus 5. They are also consecutive odd numbers, but it is often easier to use 2n minus 1 and 2n plus 1, because then when you're multiplying out brackets, the positives and negatives cancel, or if you're adding terms, the plus 1 and the minus 1 will cancel. So that is why it's nice to use 2n minus 1 and 2n plus 1 rather than going up to 2n plus 5. The last key fact you need to know is that a word integer is a number. So you need to make sure that you know that we are dealing with integers, which are all numbers. Now, once you have proved your statement, you must write a conclusion at the end of it saying that therefore you have proved what you were trying to get to or what you've been asked to do. So make sure you've included that you've proved it. Now, here is a typical type of proof question. So you have got to prove that the sum of any 3 consecutive numbers or integers is a multiple of 3. Now, first of all, on any proof question, highlight the keywords in the question. So the keywords are prove, that's what you've got to do. The sum, 3, consecutive, integers, multiple of 3. Now we're going to look at the key facts in this question, what these keywords mean. So the first key word up there is the word sum, and that means add. So you're going to be adding together terms. And specifically, we're going to be adding together 3 terms because we have got 3 consecutive numbers. So the word consecutive means in a row. So I'm looking for 3 numbers in a row. Now these 3 numbers in a row can be any 3 values. But if it is easier, when you're looking at these three numbers, you can start with the number n minus 1, then the number n, and the number n plus 1. Now, that is one order that you can have the numbers as. You could have also had n, n plus 1, n plus 2. The reason it is nice to have the n minus 1 at the front is because when you add the terms together, the plus 1 and the minus 1 will cancel later on. So it is really handy to use this one with the negative in here to make your life easier later on. It will still work if you used n, n plus 1, n plus 2. But to make life easy, we're going to use n minus 1, n, and n plus 1. As I said before, an integer is a number. And the word multiple means it is in the times table of. So in this question, it is in a multiple of 3. So the number is going to be in the 3 times table. So we've got all our key facts we need to be able to answer this question. Press pause, have a go at answering the question, and then press play when you've got an answer. Well done, guys. Give me a like and a smiley face if you've got this question correct. Well done. So first of all, we should have written down the 3 consecutive numbers. So my first consecutive number is n take away 1. My middle one is n, and my third one is n plus 1. Now, if I combine these values here, the number of n's, I've got 1n plus 1n plus 1n, which gives me 3n. Then I've got a take away 1 plus a 1, which is 0, which just leaves me with 3 times n. Now, 3 times n is 3 times by any number. Now, 3 times by any number will always be in the 3 times table, which consequently means it's going to be a multiple of 3. And if it's a multiple of 3, that means we have proved it. So we have proved that the sum of any 3 consecutive numbers is a multiple of 3. So not only have we showed it algebraically, we've also written some words down as well to show that we have proved it. And it is really important that you state that you have proved your proof at the end. Make sure you've written this down. Give yourself a tick if you got the answer correct, and well done, guys. Here we have a more complex problem on algebraic proof. It's slightly longer than the last one, and we're going to see that we can do this question together. So first of all, we need to highlight the key words in the question. So the first key word is prove, and the multiple of 8 is what we are proving. So we've got to prove that the expression n plus 6 all squared take away n plus 2 all squared is a multiple of 8. Now the key facts that you need to be able to answer this question are that you need to know that a bracket squared means that bracket times by itself. So for example, if I had a plus b all squared, that is going to equal a plus b times by a plus b. We also need to know the word multiple means in the times table of. So our answer must be in the 8 times table, and that's what we are trying to prove. Press pause, have a go at doing the question, and then press play when you're ready to hear the answer. Fantastic. Now you've got an answer. Give me a big thumbs up and a smiley face in the comment box below. Well done. And we're going to mark your answer and see how you've done. So get your purple pens ready to mark your answers. So first of all, in the exam, you would get a mark for writing down that n plus 6 squared is the same as n plus 6 times by n plus 6. And n plus 2 all squared means n plus 2 times by n plus 2. From here, we're going to expand the brackets. So the first bracket we're going to expand on the left-hand side is the n times the n, which gives me n squared. Then I've got n times 6, which gives me 6n. I've got 6 times n, which is also 6n. And then 6 times 6, which is 36. Now, this bracket multiplied together is take away the next 2 brackets multiplied together. So I've got to subtract the whole lot of the second 2 brackets multiplied together. And we're just going to leave that minus and the bracket at the front. So I've now got n times n, which is n squared. I've now got n times 2, which is 2n. I've got 2 times n, which is 2n. And 2 times 2, which is 4. So we've expanded both of the brackets. From here, we need to collect the terms and expand out the brackets. So to start with, I have got an n squared here, which just remains exactly the same. Then I've got a 6n plus a 6n, which is going to give me 12n. The plus 36 stays the same. From here, I've got a minus the whole lot of each of these terms. Now there is no number in front of this bracket, so it means there is a magic 1 in front of here, so it means -1 times each of the terms in the bracket. So I'm going to have a -1 times by n squared, which will give me minus n squared. I'm going to have a -1 times the 2n plus the 2n. Now the two n's together combine to give me 4n, so -1 times 4n is -4n. And the -1 times the 4 gives me a -4, which gives me this expression here. From here, I'm now going to simplify. So I can look at my n squared. You can see I've got an n squared here, and then I've also got a take away n squared here. So these n squareds can cancel. So n squared take away n squared gives me nothing. I'm now going to look at my n's. So I've got a 12n, take away a 4n, which is going to give me an 8n. And then I've got a 36 take away a 4, which gives me a plus 32. From here, I can see that both of these numbers have got a factor of 8. So I'm going to factorise into two brackets. So 8 times n gives me 8n, and 8 times 4 gives me 32. So taking a factor of 8 out the front gives me 8 bracket n plus 4, because 8 times n gives me 8n, and 8 times 4 gives me 32. Now, once I've got it in factorised form, this means I've got 8 times by a number, and this could be any number. N plus 4 will be any single number. But if I multiply this number by 8, it is going to be a number in the 8 times table. So 8 times any number will always be a number in the 8 times table, which means this will be a multiple of 8. Therefore, we have proved it. Now remember, when you've proven an expression, you must always state at the end, therefore you have proved, or QED at the end, to show that you have proved it. Give yourself a big tick if you've got this correct, and give me a big thumbs up if you've got the answer correct. Fantastic work, everyone. Well done. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time.